So now we are going to reflect across the line x equals 4. If you remember, yesterday we reflected across the line x, which is also known as the x-axis, and we reflected across y, which is the y-axis. So today we're going to actually reflect across another line, which is not any more difficult than what we did yesterday. So the first thing that we're going to do is we're going to plot our points just like before. So we're going to plot the point 1, negative 1. So we start at the origin. We go 1 to the right and down 1. And this is my J. Then I'm going to plot the point 2, 3. So I'm going to go 2 to the right and up 1, 2, 3. This is K. And then I'm going to plot the point 3, negative 2. So I'm going to go 1, 2, 3 to the right and down 1, 2. And this is L. And I'm going to connect my points. And now I have my first triangle. I'm going to reflect this across the line x equals 4. So we go to the x-axis and we find where x is 4. So this is 0, 1, 2, 3, and 4. So that's right here. The line x equals 4 is a vertical line. So we're going to create a line, a vertical line, at x equals 4. And that's going to be the line that we translate across. So I'm going to start with J, which was my first point, and it is 1, 2, 3 points away from the line of reflection. So I'm going to make sure if it's 3 points across on the left, it has to be 3 on the right. So I'm going to count 1, 2, 3, and this becomes my J prime. I'm going to do the same thing with K. K is 2 points away, so on the left, so I'm going to make sure it's 2 points on the right. And this becomes K prime. And then L becomes 1 point away from the line of reflection on the left, so on the right side of the line, I make sure it's also 1. Now I have my 3 points. I connect the dots. And I have reflected the image, the pre-image, JKL, across the line x equals 4. And I've gotten a new image, J prime, K prime, L prime. Now we need to find the ordered pairs for this. So we start with J prime. And so J prime is here, so I have to count 1, 2, 3, 4, 5, 6, 7, and down 1. So my new point here is 7, negative 1. Then I'm going to count for K, 1, 2, 3, 4, 5, 6. And I'm going to go up 1, 2, 3. So it becomes 6, positive 3. And then I have L prime. So I'm going to count across 1, 2, 3, 4, 5, and then go down 1, 2. So my point is 5, negative 2. So this is the new ordered pairs. So I want you to try the other one by yourself. And the only difference is that the line is going to be x equals negative 1. And x equals negative 1 is right here. So that's going to be your line of reflection instead of x equals 4, which is what we used on the previous example. So now I want to show you how we're going to do example 7. So I have parallelogram CDEF, so I have to graph that first. C is negative 4, 4. So I'm going to start in the middle, negative 4, 1, 2, 3, 4. and then down 1, 2, 3, 4. That's C. Then I have D, which is -2, 0. And I have E, which is 6, 1. 1, 2, 3, 4, 5, 6. Up 1. And 4, -3. 1, 2, 3, 4. 1, 2, 3. This was E, and this was F. Now I connect them. Make sure you use a ruler so you have nice straight lines. Now I'm going to reflect that across the line y equals 2. So in the previous example, we had a vertical line. So when we have the line y equals 2, we're going to go up to where y equals 2, and we're going to draw a horizontal line. This is my line of reflection. And now I'm going to use that to reflect the image. So I'm going to start with C. C is 1, 2, 3, 4, 5, 6 away from the line of symmetry or the line of reflection. So I need to make sure it's 6 above. 1, 2, 3, 4, 5, 6. And I put a point. Then I have, so this was C prime. And I have D, which is 2 away from the line of reflection. So it needs to be 2 away here also. So this is D prime. E is 1 away, so I make sure it's 1 on the other side. So this is E prime. And then F is 1, 2, 3, 4, 5 spaces away from the line of reflection. So I make sure it's 1, 2, 3, 4, 5 places away on the other side of the line. So where our picture started below the line, now it is above the line. And we need to connect all our points. And our new image is above the line. Now we need our new points. So we have to use our rules to find those. So we start at the origin. C prime, first thing you have to do is go left. So it'd be 1, 2, 3, 4. And then we're going to go up 8. So it'd be -4, +8. Then D, you're going to go 1, 2 to the left and up 1, 2, 3, 4. So since I went left, that's -2. And since I went up, that's +4. E is right here. So I start at the origin. I go 1, 2, 3, 4, 5, 6 to the right and up 1, 2, 3. So since I went to the right, that's +6. And since I went up, that's +3. And then F prime, start at the origin, 1, 2, 3, 4 to the right, and up 1, 2, 3, 4, 5, 6, 7. 4, +7. And that's how you get the image for number 7. You're going to try and do the same thing with the triangle for number 8. And your line of reflection is y equals -5. Y equals -5 falls below the origin. So 1, 2, 3, 4, 5. There's your point. Your line. Remember, when you have y equals, it's going to be horizontal. So you have to graph above and you have to graph below. Now let's move on to graphing if there is a diagonal line. So the diagonal line y equals x is, if you remember, your slope for y equals x is 1. So slope is rise over run. So this would become y equals 1/1 because we got to have a fraction. So that means my rise is going to be 1 and my run is going to be 1. So if I start at the origin, I'm going to rise 1, run 1, put a point. Rise 1, run 1, put a point. Rise, run, put a point. Rise, run, put a point. rise, run, put a point, and so on. And we can continue this in both directions because remember, lines are straight and they're linear as of right now. And so we're going to continue this line all the way into both corners. So the line y equals x goes like this. So this is going to be my line of reflection. So now I have to graph my points. So I have a triangle and the vertices are at -5, -2. So I start at my origin, -5, so that's 1, 2, 3, 4, 5. -2 means I go down 2. Here's my first point, that's x. My second point is -3, 4. So 1, 2, 3, up, 1, 2, 3, 4. My next point is -1, +1, so I'm going to go 1 to the left and up 1. And this is z. Now I'm going to connect. Now I have to draw the same picture but on the other side. So we're basically still doing the same thing. We're still going across the line. So whatever point we have here, we need to make sure that we have the exact same point on the other side. So if I slide 1 this way and then a half, and then that means I have to slide a half and 1 this way. So I would put a point right there. So this would be x prime. Now on this one, if I go to the other side, I would go 1 across. So I would go 1 across here. So that would be z prime. And on this point, I would go 1, 2, 3 and a half. So I would go a half and then 1, 2, and 3 and put a point right there. That would be y prime. So then I connect. All right, so there is my image. Now I have to find the ordered pairs for that image. So now I start here. Let's start with z. So we're going to go 1 to the right and down 1. So right is positive and down is negative. Then we're going to go and let's do y. So I'm just going to start at the origin. 1, 2, 3, 4 to the right, down 1, 2, 3. So 4, -3. And for x, I'm going to go 2 to the left and down 1, 2, 3, 4, 5. So -2, -5. Now if we compare the original points to the new points, what can you tell me about the ordered pairs? That's right, they are exactly switched. So in the first ordered pair, I had -5, -2. Then that turned into -2, -5. So all we did was switch our x and y to become y and x. So we still graph it the regular way, but we switched our x and our y. And that's basically the only change when you have, when you're reflecting across the line y equals x. Now I want you to try the rectangle. Remember the rule is switch your x's and y's. So if g is 2, -1, that means g prime is going to be -1, 2, because we're going to switch our x and y. And so if h is 7, -1, h prime is going to be -1, 7. So now we need to do the last example, which is number 11. We're looking at square ABCD with vertices at -1, 3, 0, 6, 3, 5, and 2, 2. And we're going to reflect that across the line y equals -x. So now, instead of having 1 over 1 as our slope, we're going to have -1 over 1 because we have a negative slope. So instead of going up and to the right, I'm going to go down and to the left. Down and to the right. And then I'm going to go down and to the right. Down is negative, right is positive. Down is negative, right is positive. Down and right. And I'm going to continue that. And so this is the line y equals -x. And I'm going to reflect across that line. So I'm going to graph my points first. -1, 3. So go 1 to the left and up 1, 2, 3. Make a point. Then I'm going to do 0, 6. 0 means no left, no right. I'm just going to go up 1, 2, 3, 4, 5, 6. This is B. That was A. And I have C, which is 3, 5. 1, 2, 3. Up 1, 2, 3, 4, 5. Which is C. Then I have D, which is 2, 2. So I go 2 to the right, up 2, and that is D. And I connect my points. Now I need to graph the same thing on the other side of the diagonal.
If you have any students who have MacBooks checked out, they could bring those to the front office. And also we have high school and middle school cheer packets available in the front office.
Since A is 1 across, I'm going to make sure I go 1 across on the other side to A prime. For B, I would count 1, 2, 3. So I'm going to count 1, 2, 3 to the other side. For C, we have 1, 2, 3, 4. So I'm going to count 1, 2, 3, 4 across diagonally for C prime. And D is 1, 2. So 1, 2 on the other side, which is D prime. Now you connect your dots. Okay. So now I want you to figure out how the ordered pairs changed and use that same information to work number 12.